This puzzle is called Patchwork Pumpkin by Blobz, and I got it from the where did I get it? I got it from the Discord Puzzle Archive on the CTC community Discord, and it is between a 2 and a 3 difficulty. That's just based on the ratings that difficulty ratings that I see listed there. So let's go through the rules real quick. The gray lines are repeated digits. I think these are just palindromes, so let's say this is a 5, then this must also be a 5. If this was a 3, then this is a 3. That sort of thing. Did I skip? Oh, I did skip a line out here. Digits separated by an X add up to 10, so if we found this was a 3, then this would have to add up to 10, so this would be a 7. Pretty simple. And similarly for V's, these add up to 5. So if this was a 2, this would be a 3. Let's see. And not all X's and V's are shown. That's important, of course. The green lines are German whispers. So let's say that we discovered, yeah, how do I want to say this? Green lines are German whispers, which means that the adjacent digits differ by at least 5. So if we discovered this was a 3, this would have to be 8 or 9 because those are the only digits that are at least 5 away from it. Okay, so this is the big area, or the big rule. Okay, I'm just, sorry, I'm reading ahead. So the indicated 60 cell white region, so everything besides these grayed regions, contain one of each of 12 standard pentominoes, which they provided a picture of several of them, or of all of them, not several. That would be weird to provide a list of just some of the pentominoes. And with no repeats, so we just have the 12, which will fill up perfectly the 60 cells. Each pentomino is stitched to 2 other pentominoes by a green or gray line. Okay, so what I think that means is, let's say, well, that's 6 cells, so that couldn't be it. Let's say this was a blue. This was a region that we came up with. This is the P pentomino. Then this is stitched to this other pentomino over here from this this line, and then it's also stitched to this one. So this could be let's say like this, and I mean that's obviously a broken situation, but that would be valid as the rules present themselves so far. Once placed, each pentomino behaves like a 5-cell killer cage. Yeah, digits do not repeat and must sum to the value listed in one of their cells. Okay, so that's going to be interesting. I'm going to have a link to the puzzle in the description down below, and a link to the pentominoes down below. I don't have the technology to make it pop up on the screen. Actually, maybe I can. Just give me a moment here. Okay, we're back. I just figured out how to add it to OBS. So, it should just be a quick cut there. Hopefully not too I don't know, whatever. So yeah, I just have an image placed over that, so you can't see my mouse while I'm down in the corner here, but I think that'll be okay. I figured that was better than covering up the rules for you guys. Okay, so let's get started. Yeah, the links are going to be in the description down below. And so the first thing I realize is that each of the cages each of the pentominoes must touch exactly one killer cage value. So like these two couldn't be in the same cage because that would be 2 different numbers and that wouldn't make sense. So this is one of the cages. Okay, so I was just wondering if V's and X's could also stitch together, but no, it's only the lines that can stitch together. So this is one color. This is a different one. And yeah, each one of these is going to be a different color. So let's just go around and color these a little bit. Actually, let's... Let's just make the colors more varied because, like, obviously these are gonna end up touching somehow. So let's just make sure that they aren't similar colors. That's pretty different. And then here's a yellow. And over here, let's use a purple again. And over here, let's just use blue again, I suppose. And that's another close one. Let's use red, and then a green can go over there. And what should we do for the last one? Let's use yellow, I guess. Okay. So we know that these lines are stitching, so this does not connect to this. Wait, do we know that? We do know that the pentominoes are stitched together, but we don't necessarily know that every line indicates different regions. I don't think. Maybe we can determine that by the... Let's see, there are 12... There are 12 pentominoes, and each one needs 2 lines, which would be 24, but of course they double, like, they're used twice. Like, so we would divide that by 2. So there should be, if there are 12 lines, I think. Is that logic correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I think that every line also indicates different regions. Let me think about that a little bit more. I want to convince myself rather than just... So there are 12 regions. Each one has 2, which would be 24 lines total in some weird universe. But, of course, each stitching is counted twice because it's in, let's say, region A and region B. So if we divide that we divide that count by 2, back down to 12, that would be, yeah, I think that's right. So each time that there's a stitching, let me recount these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, each time there's a stitching, that means that there must be a different cage, different pentomino. Okay, so that's actually going to be hugely helpful. So, like, what could this be? If it's not purple, it must be yellow. That's the only way to get around the eye. If you didn't notice, by the way, you can't really see on this because they took out the colors, but it's a pumpkin, jack-o'-lantern with eyes and a mouth, and yeah, eyes and a mouth. So anyway, to get around the eye, it has to go this way. That's the only way to get. And then it takes this one because that's the only way to get 5 digits for yellow, or 5 cells for yellow. Let's see, what's another one? Here's yellow. Yellow comes here. This must be purple. And also, well, we could have looked at it the other way, and purple must come this way, and it must go up that way, yeah. This must be blue. It can't get over to, like red couldn't get this far. That would be much more than 5 cells. So this must be blue, and it must come this way. Oh, 1, 2, yeah, this must be blue as well. Yeah, I guess this must be blue. Yeah, that's a good way of thinking about it. Is that this can't be blue, and how does this? So this must be red, and how does this get over to red? It must go like this, which, claims this cell. So this must be blue like this. Now, what can this be? It must be green. Green can just continue on like this. Let's see. Oh, green up here. What can take this? It must be orange. So we go around the eye that way. Oh, did I never color this cage? Does that mess me up yet? Let's make this purple, I guess. I don't think that's messed me up because I've mainly been going around the edges. I think I'm okay. Well, green must come here, and then come here because that's the only way it can go around. And if this was red, if this came over like this, then green would be blocked off from getting more digits. So I think this must be green. Oh, wait a minute. No, not necessarily. This could be blue. Yeah, that's true. This could be blue. Yeah, okay. What could this be? If this was red, then this would be 5 cells for yellow. Have I used P? I've already used P. This is the P pentamino. If you churn it, it kind of looks like a P. Um, so if this was red, then yellow would be forced to be into. If this was red, then yellow would be forced to be into a P pentamino, and we can't repeat pentaminos. Also, this cell, what is this one? That's the N. This N pentamino would be repeated as well. So it's definitely not like that. Uh, so this can't be red, it can't be purple, it must be yellow, I believe. Which means yellow, yeah, this must come upwards, and it must connect, because if this cell is not yellow, then what color is it going to be? I think it must be yellow, yeah. Yeah, so could this not be yellow? And my first thought was, yes, it could be red, but if we did that, then this red region and this yellow region would be um, the same pentamino, so that's not allowed. So this is yellow. And I haven't been paying attention to the 2 stitching rule, but I think so far I'm right on that. But maybe that'll come into play when we get into the middle. Oh, and this must be a purple, just because it has to get out. Yeah. Okay, so this cell can't be yellow, can't be orange, of course. The orange can't get there. Could it be, if this was purple, like this, then this would be, what is that, a V? This would be a V. And that would be the same as this big orange over here. So this can be purple, so this must be red, because that's 6 digits, or 6 cells away. So that'd be too large. So this must be red, which means it must come out like this. So where does it connect from here? It can't be here. If this was red, then it would be the same shape as this. So this can't be red. So one of these are red. Have we used... What are these? This is the Y. Have we used a Y yet? I don't see that we have. Have we used a T yet? I also don't see that one. Okay, so we don't know. We still need one more cell. Let's mark it like this so we remember that. Oh, this one just can't be, of course, this one can't be red because it would be this, the stitching has to go across regions. So it is a T. And this purple must come out. Okay, so this is a different region, but this could probably be just about any region. Any region left, yeah. Because it could go like this, it could go like this, could go like this. I guess it couldn't be this purple. But I guess marking one option off the list of 5 isn't that helpful. We might be able to uniquely do this with... I need to start... I don't have a good way of like marking off which ones I've done. Like in OBS, I mean, like putting an X, you can't see where my mouse is, but like putting an X over F, let's say. Although I don't think we use the F. So we haven't used F. That is actually good to know. We haven't used F. We've used I. We've used L. We've used N. We've used P. We've used T. We've used U. I don't think we've used W. So F and W. We haven't used X. We've used... No, we haven't used Y. And we did use Z. So it's F, W, X, Y. Okay. That's gonna be a little tricky to fit in. F, W, X, Y. So which ones could be Y? This can't be a Y. This can't be a Y. So this one could very easily be a Y. And actually, that actually shows me a good question to ask. What color could this cell be? It can't be blue because it has to go across, the stitching has to go across regions. It can't be green. And it can't be this purple because that would be too many cells. Even if it went like this, that would be 6 cells. So this must be purple, and it must be this purple. And I think the only option left once we have 4 in a row is Y, which goes like that. And it does have 2 stitchings now, so that's good. Okay. So this cell can't be this purple, can't be this purple. So this is green or blue. This is purple or blue. This is blue or green as well. Yeah, no, and these are different. I should point that out for a couple of reasons, but um, each, like, blue has 1 stitching and green has 1 stitching. So whichever one takes this will have their 2nd stitching, so this one, so they can't also take this one. Yeah, let's see. So this is... Okay, so we used Y, so we need an X still. So where can X be? Yeah, where can an X be? Purple can't be X. Green can't be X, and we only have 3 regions left. We have these 3 regions left. And if purple and green can't be X, then blue must be X, which means it must go like this, because it can't go horizontal. Whoops, it can't go horizontally because that would break up this region. So it must go vertically. So that must be blue. This one is not blue. And then that resolves this. I'm going to change this color because we ended up... I didn't think there was a chance of these two touching each other, so I chose colors that were far apart. Let's just do orange, I suppose. Yeah, I didn't think those were going to touch. They're so far away. But they kind of beelined for each other there. Okay, so we have the pentominoes done. We have all the killer cages done. So let's start filling stuff in. The first thing that I see is... There's a couple things. This 17 cage has an X in it, which means this is going to add to 10, which means the remaining digits have to add to 4 in 3 cells, which has to be 1, 2, 4. So this has to be a large digit, but that doesn't necessarily narrow things down very much, because the only way to make 34 in 5 digits is 4, 6, 7, 8, 9. So we have that one done. Would it be helpful to use the line tool to... I don't know. I don't know if it would be helpful. I don't think I need to. 31 has a little bit more options. But this is 21 in 3 cells because this is obviously 10. Is that helpful? I mean, it is pretty restricted, but it's not so restricted that I can't do anything. Okay. These are the same digit. Does that matter? I guess it's not 1, 2, or 4. Oh, if it's not 1, 2, or 4, this must be 3, 7. Of course. So this is a 3 or a 7. Yeah, if we're already using 3 of the 4 low digits, then the 10 pair is going to have the other low digit. That's just kind of simple, I don't know, simple logic. This line must have a low digit and a high digit. It has to, because of the way that German whispers work, you're going to have a digit that's less than 5, and then a digit that's greater than 5. Because even if you have the lowest digit, a 1, you can't then put another low digit next to it. Because of course 1 plus 5 is 6 already. So this is going to have a low digit, but we've already used 3, and we've used 2 of 1 and 4. So in here, this line is going to have whatever this digit is. I don't know how helpful that immediately is. I guess the rest of the line, the rest of the row must be big digits, or a 5. And this can't be a 5 because if you put a 5 on an X, it must be 5 and 5, of course. Actually, speaking of 5s, let's look at this column. 5 can't be on an X, can't be on a German whisper, and can't be on an X. So there's a 5 all the way down here. I guess we don't know exactly where it is, but that could be helpful, maybe. Here's another 17 cage, which I guess doesn't have an 8 or a 9. I don't know if that's helpful, but it could have all the way up to a 7 if it was 1, 2, 3, 4, 7. Oh, yeah, let's use this V, I suppose. This is Okay, yeah, that's good. I should have noticed this. Yeah, this is 1, 2, 3, or 4. If we tried to make this 1, 4, well, then both of these cells would be 2, which obviously isn't allowed. So it must be 2, 3, which takes the 2 out of this, and places a 2 here. So this has a 1 or 4 on it. And actually, these can't be 4. Oh, I could have ruled 4 out of this anyway because it's a low digit, but whatever. So this can't be a low digit either because it's a 2 or 3 there. And actually it can't be a 6 either because 6 forces a 1 next to it on a German whisper. That's the only digit that's 5 away from it. So it must be at least a 7. So this is 5, so this adds up to 21. And it needs to have a 5. We haven't used a 5 in the column yet. So that means it must have a 9 as well. If it must have a 5, then it must have a 9, because the only way to make 21 without 9 is 6, 7, 8. And that doesn't work anyway, because that would break these cells. But so it must have a 5 and a 9. And that's 14, which needs a 7 to go along with that, so that's 5, 7, 9. And 5 can't be on the German whisper, so these can't be 7 or 9. And now these can't be 6 or 8. Wait, what did I remove? Oh, I added the 6 to that cell. Like, wait a minute. I just pressed to remove 6 and 8. Why is that still there? Okay, so this can't be a 7. If this was a 7, whoops, if this was a 7, that would put a 3 on the opposite side of the X, which would break this V over here, so this is not a 7. So we have 7s down here looking over to the right. Don't know how helpful that is. This is a 1 or a 6, which could have some trouble with these 6s, but this could also be the 6, and then this could be a 6 just fine. This must be a low digit, but it could be any low digit besides a 2, I guess. There's a 2 looking down, because 4 would go fine with 9. Let's see. This is a 23 cage. So without this is 13. That's not so restricted. We do have a 3, 7 looking down, so this is not 3 and 7. Oh, and also we know that... Okay, we can actually... Okay, yeah, there's a little bit of logic here. So where can 5 go in this box? We haven't placed it yet. We haven't even given it as an option yet, so it theoretically could go in one of these 2 cells. But if we placed a 5 here, it would go there, and then we would have 5 on an X that would break that. So this can't actually be a 5, so this is the 5. So what can this cell be? I guess 1 is in one of these 2 cells. So this could be a 1. Can't be a 2, can't be a 3. 4 is going to be in this cage. So it can't be a 4, can't be a 5. It could be a 6, I think. Whoops, it could be a 6, and it could be an 8. I think those are all valid options at this time. Oh yeah, and this would be, because this is a 4, 7, 9 triple, this becomes a 1, 6, 8 triple. Yeah, that looks like it's right. So now this can be a 1, 6, or an 8. Yeah, that could be a 1, 6, or 8. So this option, 2, 9, and 4. I was kind of hoping one of these options would break something, but I don't know that it will. So if this is, say this is 9, 1, then this couldn't be a 1, and this couldn't be a 1. Yeah, that's fine. Darn, with all the 4s and 6s in this area, I thought that maybe something would break, but I don't think it does. If this is a 6, this is a 1, this is a 9, this is a 4, this is a 4, yeah, that works just fine, it looks like. Okay. I guess we could look up here. This is a 1, 2, or 4, just based on the X. Can we do anything more with this German whisper? It's a 1 or a 4. It's whatever this digit is going to be on the line. But unfortunately, the other digit, the high digit, could be a 9 if it wants to be. So that's pretty large. Well, let's look at this cage. We have an X in it, so in total this sums up to 23, but this sums up to 10 of it. So we know these three sum up to 13. If we try to make this a 7, things get pretty restricted. 7, 5, 1, actually that works. 7, 5, and 1. Darn, I thought that was gonna, for some reason I thought that was gonna break. What about 9? If this was a 9, this could be a 3 and a 1. Well, that works too. Okay. I guess the only reduction here is that it's not 3, 7, so we still have the 3 other 10 options, the 3 other 10 pair options, I mean. What does this sum up to? This sums up to 23, so these sum up to 13? Is that restricted? No, I don't think so. I do not think so. Okay, let's see. These cells must be the same. And okay, what can this cell be? It can't be a 1, because one of these is going to be a 1. Because one of these is going to be a 1. So this can't be a 1, but it could be a 2. It can't be a 3 because if this is a 3, then this would be a 3, and it sees a 3 there. Could both of these be 4? If both of these were 4, if this was 4, this would be 6, this would be 9, this would be 9, 1, this would have to be 2, 8. I think that all works. I mean, maybe eventually it would break, but I don't see any problem with 4 right off the bat. It couldn't be 5 because it's on an X. It couldn't be 6 because if both of these were 6, then it would break this pair over here. It couldn't be 7 because there's the 7 there blocking it from there. It couldn't be 8 for the same reason as 6. It would remove 8 as a possibility from that pair. Could it be 9? These were 9. This would be 4, 6. Then this couldn't be a 4 or a 9, so it'd have to be 2, 8. I think that's fine. I think that's fine. So what are the options for this? That's 1, 6, and 8. Oh, this same as the cell next to it, I guess. Let's see. So if these add up to 13, is this actually possible? So this adds up to 23 total. Minus 10 is 13. So these 3 cells, let's just give them a little bit of a flashing right now. Actually, let's not do black. Let's do gray. Actually, that's not helpful either. I just want to make it obvious which cells I'm talking about. But if this was a 9, then 6 would be way too large. So this would have to be a 1. If this is a 9, this has to be a 1, which actually breaks the puzzle right away. I was going to say then it would require a 3 right here to sum up to 13 and break this. But if a 9 requires a 1, then it breaks right here as well, because this cell would require it to be 9 because of the 1 on the X. So this is not a 9. Okay. So this is not a 1. If this was a 6, this would be a 4. Again, I'm like, 6, okay, this is a 4, but this can't be a 3. When there's a much more obvious deduction that 6 forces a 4 here and rules out 4 from that cell. So if this is a 6, this must be a 2, which adds up to 8. And we need 13, so this would have to be a 5. I think that's fine. That would be an 8, and this would be a 1, 9 pair. That seems to be fine. Okay. I was just, yeah, what if this was a 1? This would have to add up to 12, which would have to be 4. Oh, that actually causes problems. Okay, if this is a 1. Wait, why did I say this has to be a 4? Why did I think this had to be a 4? If this is a 2, oh, because it's 13. I keep thinking I'm adding up to 12. No, I'm adding up to 13. So if this is a 1, then 2 would require a 10 in this cell, which isn't possible, obviously. So this would have to be a 4. So then we have 1, 4, and we have 5 total, so we need an 8, so we put an 8 here. But then how do we fill this? We've just ruled out 1, 9, we've ruled out 4, 6, and we've ruled out 2, 8. So 1 doesn't work at all. This must be a 6, which puts a 4 here. And is actually going to just do a lot of work around the grid here. Yeah, this is 6 forces a 1 on a German Whisper. This can't be a 6 or an 8 now, so this is a 1. So this is a 1, so this is a 9. This 4 looks over here, so these must be 2. This must be an 8 because of the X here. This is 8, which means a 5 is right there, which works just fine. This can't be a 5 any longer. Oh, we now know that there's a 1 on this line. Oh, we don't know exactly where, but we know one of these two. Unfortunately, 1 can go with any high digit, so that's not too restricted. This can't be an 8 because there's an 8 right here looking up. So this is 1, 9 or 4, 6 because it can't be 2, 8 and it can't be the 3, 7 over here. I just noticed this 1 is going to remove 1 as an option there, but also remove 1 as an option there. So this can't be a 9 any longer. Wow, that little piece of logic there just got us so many digits. That was nice. Okay. What's left here? There's a 6, 9 here and a 6 or a 9. Whoops, a 6 or a 9 here. So whatever is here, whatever is in this pair is the opposite one. The other one is going to be here. So we can't use 6 and 9 here. So we have 1, 4, what is it, 8? Yeah, 8. 8 is the other digit that we're not using yet. Okay, so we can't use a 4 here because we have a 4 in the row. We can't have a 1 here because we have a 1 in the row. I think that's correct. So if this is 8, then this is 1. If this is 8, this is 6, yeah, that's fine. I was thinking that we would force a 1 here and here, but I literally just started with an 8, so that's fine. Oh wait, no, that does cause a problem. In a different way. If this is an 8, then this is a 6. What's possible for this cell? This must be a 4. But what does this cell have to be because of the X? It must also be a 4. So this can't be an 8. This must be a 1. Oop. So then this can't be a 1. This can't be a 9, which puts the 9 there. Now that can't be a 9. And that's actually the last spot for a 5 in the row. I didn't notice that. When I removed 5 over here a while ago, I could have placed that, but it didn't really matter, I guess. This is a 6 or an 8, just to go along with whatever that is. Oh, this must be an 8, because we have the 4, 6 pair. Okay, what... Can we maybe restrict some cells in here? Now I'm just looking that 8 is restricted down here by this, but I kind of feel like there must be some more. 5 is restricted up to here. Actually, no, we have 2 5s looking in, blocking all of those. So that's a 5. 3 and 7. This 3 and 7 needs to go in there. A 9 needs to go in there. Oh, yeah, I guess those are the other two numbers. We have a 3, 7, 8, and 9 are the last 4 digits. Okay. So 6 is looking down. And it can't be there. I saw, the reason I said oh is because I saw 1 is also doing that, but 1 can be there. I was thinking we were going to get a 1, 6 pair, but that's not the case. Okay, making some good progress. Let's look back over here. What can this be? It can't be, it could be 1, 9. It can't be 2, 8 because of the 2. Could be 3, 7. Can't be 4, 6. Oh, there's a 6 right there. Speaking of 4 6s. I don't think that, I mean, it's obviously good to get digits, but I don't think that resolves too much or anything. But that's fine. Okay, let's look here at options. It could be 1, 9 if it was situated like this because of the 9 here. It can't be 2, 8 because the 2 and the 8 are, or sorry, the 2s are both looking over here. It could be 3, 7 in either configuration. And it can't be 4, 6 because we have both 4s and 6s looking over at this. So that's a bit restricted, but not. So this, oh no, I forgot about this line. This is because of this line, this is a 3, 7, or 9, but now we have a 9 looking at this, so this can't be a 9 any longer. So this is a 3 or a 7, which means this is not 3 or 7. What is this? This is 8, 3, or 7. Which leaves this as a 9, the last that last remaining place for a 9 in the box, which puts a 9 there. 7 forces this to be a 2 because of the German Whisper. 3 plus, or 7 minus 3 is 4, which is obviously not enough. Okay, we have a 4 here in the column now. Scanning up and down here. This can't be a 7, I suppose. Don't know how helpful that nugget of knowledge is, but better than nothing. So this is 2, 4, 3, 7. Yeah, that's not helpful. It's whatever 2, 4 is not here and whatever 3, 7 is not here. Unfortunately, that kind of makes for a lot of options. What about this row? This is 1, 5. So this is 6, 7, 8. Oh no, we have a... Oh, well this can't be a 7 any longer, because this is a 17 cage. If this was a 7, this would have to be 1, 2, 3, 4. But we already have a 5 in the cage, so this must be a 7. No, sorry, it must not be a 7, it must be a 3. Go through a whole bunch of logic saying, this can't be this digit, and then immediately write it in. That's exactly something I would do. Okay, we got a bunch of logic, a bunch of info there. What's this last digit? Is like a 6 or something? Yeah, so we have a 1, 2, 3, which adds up to 6. So we need something to go with the 5, or I guess we could look at it this way. 1, 2, 3, 5 adds up to 11, so this has to be a 6 to add up to 17. That's a better way of phrasing that. This still has a lot of options. Let's ignore that for the moment. Let's look at this column. This is, or could be a 2, 4, or 8, it looks like. Yeah, 2, 4, 8. And unfortunately, I was thinking that we would be able to remove some options because we have so much in the column as well. So this is 2, 8, or 6. One thing I noticed while I was scanning there, this 1 sees this, of course. I know there's a 1 up there. So we can reduce the options a little bit more. What are these? This is 3, 4, 7. This must be a 4 because there's a 3 and 7 in the column. Okay, so if this was a 7, this would need to be a 1 or a 2 because of the German Whisper, but we have a 1 and a 2 looking in at it, so this has to be a 3. So this is a high digit, it's either an 8 or a 9, and we have a 9 right there. So this is an 8, which then resolves all the stuff up here that we've been griping about. And this is, let's see, what is this, a 6 or a 9? So this must be a low digit because it's adjacent to a high digit, and it can't be a 1, a 2, or a 3. So this must be a 4, which forces this to be a 9. And then the x, of course, forces that to be a 1. What's left is 5 and 6. So we'll just type that in down there. What's left here is 2 and 5. And there's a 5 right here. Perfect. Yeah, let's look at this column. This must be 2, 6. Whoops, 2, 6, 8. What about this column? Must be 1, 3, 5. And this column must be 4, 7, 9. So what options do we have here? This can't be a 5. This can't be a 5 either because of the German Whisper, so this must be the 5. This can't be a 4 because it would have to match with a 6. Since this is low, this must be a high digit, so this can't be a 2. Unfortunately, those options work. And we get to a little bit more options up here, so let's look at one of these cages. So this is 13, sorry, this is 22. That was a totally wrong number. Where did I... Oh, because there's a 1 and 3 there. How did I even come up with 13? Handily, there is a 1 and a 3 in that cage. So anyway, 22 minus 10 is 12. So if this was a 6, if this digit was a 6, this would have to add up to 6 to sum to 12, which would have to be 3 and 3, which technically adds up to 6, but we can't have two 3s next to each other like that. So this can't be a 6, this must be an 8, which rules 2, 8 out of this, and is going to give us a couple digits here, and this 8 again rules out and is placed there. So now we have 18, we need this to add up to 4, so this can't be a 6. This must be the 6. Oh, this 6 over here places that. Oh, and we have a 5 here looking over, so this is the last 5. Great, okay. Uh, what is the other digit? We have 4, 7, 9, and 3. Okay, so we have a 3 looking down. That's the last spot for a 3 in the row. So this is a 4, 7, or 9. Unfortunately, we don't have any digits in the column. What's the other digit we're missing? We're missing 4, 7, 9, and 8. Oh yeah, okay, so we have an 8 looking in like this, and an 8 looking down. We could have looked at it that way. So now this has to add up to 31. We have 10 plus 14 is 24, so this must be a 7. So this must be a 9, 1. I'll do that in a second. This must be like this. These can't be 9s. So a 3 on a German Whisper is forced to connect to an 8 or a 9, so it can't be a 7 any longer. This 7 looks up to there. This must be a 2. That's the only digit left there. And 4. Great. That was a lot of fun. I really like that puzzle. It's always fun to make your own regions and see how they can kind of, spread out and claim territory. And then, after that, um, had a nice killer Sudoku with some, a little bit of lines to help us along the way. That was a really great puzzle. I really like that. So thank you to Blobz for the puzzle, and thank you guys for watching.